So an alternative answer to this one, I could have used this point instead, and I would have had to do y minus negative 6, and then that same slope, and then x minus negative 2. I want to show you guys that these are the exact same thing. So let me go to a graph and show you why they're the same. So if I go to this point, I'll start with the blue one, 4, 3. 1, 2, 3, 4. 1, 2, 3. That's here. And remember, my slope was 3 over 2. So rise, run. So 1, 2, 3, 1, 2. It's like there. If I connect that about there, I'm going to go to the point negative 2, negative 6. Negative 2, 1, 2, 3, 4, 5, 6. Negative 2, negative, oh, look at that. Now I'm going to count out my slope, 3 over 2. 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. It's the same thing. Okay, that was kind of creepy. Sorry about that. All right, let's do another one. So I have my slope formula again, and I'm going to label x1, y1, x2, y2. y2 is 3, y1 is 8. x2 is negative 2, x1 is 5. 3 minus 8 is negative 5, and negative 2 minus 5 is the same thing as negative 2 plus negative 5, and that's negative 7. And negative divided by a negative is a positive. Again, I can use either point. I'll use this one first. So I have y minus the y value is equal to the slope, x minus the x value, which is already negative, so minus minus. I can equivalently use this problem, or that point, sorry. Y minus 8 equals 5 over 7, x minus 5. I'm going to show you again, these are the same thing. So negative 2, positive 3 is here. 5, 8. It's 3, 4, 5, 6, 7, 8. It's like there. How do I get from one to the other? I go up 5 and I go to the right 7. They're together. They're on the same exact line. Okay, almost done. Blast from the past, linear inequality. So I've got distributive property here. 4 times x, 4 times 2. 4 times x is 4x. 4 times 2 is 8. 2 times x, 2 times negative 3. And then I'm adding in my 4x. I've got some like terms on the right side, not on the left, but I have 2x and 4x. That's 6x. Now I start inverse operations. So I am going to subtract 4x from both sides. I'm going to add 6 to both sides. And finally, divide both sides by 2. Now, how this is written is 7 is greater than x. I'm going to flip it around and say that x is less than 7. So remember your little alligator. Alligator, alligator. Alligator's eating the 7 because it's bigger. It is still eating the 7 because it's bigger. So 7, and then I'm going less. Open circle because it's just less than. Y is less than or equal to negative 4x minus 2. Well, first thing that I notice is that these lines are all the same. The only thing that's different is dotted or solid. And I see right here that this is the less than or equal to. It has the equal to part. That means I want a solid line. The only difference here is my test point of 0, 0 right here is shaded, and my test point of 0, 0 right here is not shaded. So I'm going to test out 0, 0. Is 0 less than or equal to negative 4 times 0 minus 2? Is 0 less than or equal to 0 minus 2? Is 0 less than or equal to negative 2? Let's look at our number line. Is 0 smaller than negative 2? Nope, it's on the right. False. So that's my answer. Exponents. So I'm going to take my coefficients and divide them if I can. 8 divided by 2 is 4. So if I had something like this, like same problem, but if I change these numbers, is 5 divisible by 2? No, it's 2.5, but I don't need to do that. You just leave it. Okay, m to the third means, and m to the second means, and m divided by m, and m divided by m cancels out, and I'm left with 1m in the numerator. You can also think of this as m to the third and then minus 2. Because we're dividing, why am I getting tongue-tied? Subtract my exponents, and m to the third minus m to the second is just m to the first. Okay, now the letter D. So when I have negative exponents in the numerator, I'm going to bring them down to the denominator and make it positive. So I have in the denominator, I have d to the second power, and then I have d to the fifth power. And so together, that makes d to the seventh power. I can't simplify that anymore because m and d are different variables. Okay, last one, domain and range. So domain refers to the x values. Where's my starting point and where's my stopping point on the x's? So it looks like my graph starts over here at negative 3 and stops over here at 4. These are minimums and maximums that our x's can have. So I'm starting at negative 3, I'm stopping at negative 4, and those are closed circles on those endpoints. So I'm going to put a less than or equal to on there. And then the lowest that I go is negative 2, and the highest that I'm going is 4. And there's my domain and range. Please study. Good luck.